Flack math! Give me some math and I'll give you some flack. Flack math!
Polynomials. All right, so this is lesson 23. I just like this. I like doing this. To me, I know it's not the case for most people, but these are just like fun puzzles to solve, figure out the number combinations that work. So we're going to talk about factoring. So to completely factor a number means to express it as a product of prime numbers. So when I say like factor 18, that means I want to take that engine apart to where you can't take it apart anymore. So unscrew everything and put it all on the garage floor. So how do you take apart 18?
2 and 9.
2 times 9, right. And then, so that 2 is an engine part that won't come apart anymore, right? So that's a prime number. What about 9?
3.
3 times 3, right? So the factorization is like 2 times 3 squared, or 2 times 3 times 3. All right, those are the 3 parts of that engine that you can't take apart anymore. And together they build that number. So you can build any number greater than 1 with prime numbers. So it's either prime, like you can build 17 with prime numbers, it's called 17. Or you can build 34 with prime numbers, 2 times 17, okay? So a prime number can't be taken apart, okay? So similar to counting numbers, a polynomial is a polynomial. A prime polynomial is one that can't be factored. You can't take it apart. Okay, so 7 is prime. And if I had x squared plus x plus 1, this is also a prime polynomial. So do you remember factoring trinomials? You have to ask yourself, well, what times what equals 1, but added together will equal 1? Well, nothing. There's not 2 numbers that multiply to get 1 and add to 1. All right? So 1 times 1 is 1. Those are the only factors of 1, right? 1 times 1. But 1 plus 1 doesn't equal 2. So this is not factorable. It's not factorable. So we call it a prime polynomial. That kind of makes sense, right? Because 7 is prime because it's not factorable. We can't break it apart. Okay, so use what you know about multiplying polynomials to factor them as the first step. Okay, factor out the greatest common factor. So the steps to factoring. I'm going to write these down on this board because I want it to be a permanent fixture of the class. Steps to factoring. What's the first thing? Do you guys remember the first thing you always look for when you're factoring a polynomial? You guys remember that? Should I give you an example? Let's see what your gut tells you. Here's example 1a, 3x squared.
Is it something about the perfect square? Like get into the biggest?
That's the second step. Good job on that. But the first step, what should you always look for first?
Oh, if you can like combine anything. Like if
So
there's 2, like
that's
3.
the third step. But no, finish your thought. Actually.
Like I was gonna say, like if there's like 3x squared and plus x squared, like you combine.
Oh yeah, you do that
Combine,
first.
like,
So you always simplify it first.
Yeah, simplify it.
Okay, so before you factor it, you should definitely simplify the polynomial first. Okay, but the first step of factoring is always look for a
Greatest common factor.
greatest common factor. So always
I tried.
look for a greatest common factor first. Okay, and then is there something that goes into all three of those terms? Is there something that you can divide out of all three of those? A 3. So the greatest common factor goes out here, and you do the reverse distributive property. So take it out, strip all those terms of 3, and what do you get?
X plus 2x minus nothing.
Right, so x squared
Right.
plus 2x minus, what happens when you divide a 3 out of 3?
It goes to
It
1.
becomes just-
Goes to 1. Remember, it doesn't cancel completely. Because if you were to distribute this backwards, so you see how this is a backwards thought, very typical of algebra and algebra 2, a lot of backwards thinking. So we see how we just did the distributive property backwards. So instead of going forwards, 3 times x squared is 3x squared, 3 times 2x is 6x, 3 times -1 is -3. See how we just went backwards, okay? So you're gonna find the greatest common factor, and then how you populate this parenthesis is, okay, what do you have to multiply by the 3 to get back to that? What do you have to multiply by the 3 to get back to that? What do you have to multiply by the 3 to get back to that? Okay? So see how it's backwards thinking? It's very algebraic-y. Okay? All right, so that's the first step, and then we've got this guy here. Does anyone know what we do next?
Wait, didn't Avery say the second step?
Yeah, the second step was you're looking for look for a difference of 2 squares. Okay? Difference of 2 squares this isn't a difference of 2 squares, right? Because first of all, it's three somethings. It's not 2 somethings. It's not a binomial. It's not a difference of 2 squares. This is a trinomial, okay? And then that's the third step. You're looking for a trinomial to factor. And we'll talk about this in more detail later, but when you factor a difference of 2 squares, it's the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Okay? Or you could say the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. That looks weird, but that's if you have something like this, like x squared minus 9. Well, this is a difference, right? Difference of 2 squares, right? So to factor that, you square root the first, square root the second, one of them's added, one of them's subtracted. That's how you factor a difference of 2 squares. Yes?
Wait, so because I can't really see this. This is the square root of the first plus the square root of the second times the square root of the first minus the square root of the second.
So that's how I wrote it down, but it's easier for most of you to look at an example. So see how this is a difference of 2 squares, because x squared is a square because you can square root it. 9 is a square because you can square root it. And it's a difference, okay? To factor it, you would do the square root of the first plus the square root of the second, square root of the first minus the square root of the second. And this order doesn't matter. You could do the subtraction first, it doesn't matter. But that's how you factor a difference of 2 squares. We're going to talk about that in a little bit. But then the last thing you're looking for is a trinomial. And it's got to be factorable. And if it's not factorable, what's it called? So this is the one, when you factor a trinomial, you're doing the cheeks and tats. Makes it easy to remember. That's like one of the only, don't tell her I said that. It's one of the only things Tori could remember. Cheeks and tats! No, she remembered a lot of things, but she was always quick to...
I missed it.
Okay, so is this factorable? Remember the question you ask yourself? Yeah, what can add to the middle terms coefficient, but multiply to get -1. Yeah. The only factors of -1 are 1 and -1 or -1 and 1. None of those add to 2. So this is prime, so you're done. This is the answer. That is, what kind of trinomial is that when it's not factorable?
I have no idea.
Prime trinomial, or prime polynomial. Okay? So if it's not factorable, just like normal numbers, it's prime. Okay? All right, let's do another example. Here's 1b. Ready? 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 -4x cubed minus 10x. Factor that.
Are we supposed to like chicken scratch in these or no?
Yeah, it might be
Or does
easier.
that make it complicated?
No, not in these. It'll be easier.
Okay. Oh my god.
Okay, so this is a one-step factoring job. There's only one thing you could do, and what is it? Great.
I don't know if that's right, but I did 2x like on the outside of the parentheses.
Okay.
And then b times -2x squared plus -5.
Plus 5 if you took out a -2x, but you can take out a bigger one. You took out a common factor, but not the greatest. No, you did. You did.
Yeah.
So, sorry. Sorry, I didn't mean to doubt you.
It's okay.
She's right. I'm wrong. -2x, and you're left with a what?
So you did -2x. I did positive.
You can do it. You can do I mean, there's nothing wrong with that, but this is. It's always good to end up with a positive first term. So if that positive leading coefficient is, if that leading coefficient is negative,
Okay.
try to make it positive.
Okay.
But yeah, it's easier to do that. So if you take a -2x out of there, you're left with a 2x squared plus 5. Good. Very good.
Wait, why?
I
What?
didn't even know
I just got
that. I'm
like
done.
2
Oh yeah.
on the outside of it.
That's right. But now see how and then you're left with a 2x cubed plus 5x,
Exactly.
and they have an x in common that you can take out. So you can do it in 2 steps, or basically you just have to look for 2 things. What number goes into both those coefficients, and what variable goes into both of those variables, okay? Or what can you take out? What's the biggest biggest x you can take out?
The biggest L.
You're looking for the smallest exponent of the x. So the biggest x you can take out is just an x.
Okay.
Okay? Does that feel all right? And then you're done. The only binomial you can factor is a difference of 2 squares, and that's not. It's not a difference, and it's not 2 squares. Okay? So you're done. Good. So far, so good? So really, that part was just that first step, looking for a greatest common factor. Okay, now, there's a table in the book that I think is confusing. So I don't think I'm gonna write it down, but I love that magic question, is what factors of the constant will add up to the middle term's coefficient. So we'll do an example. We'll just start with an example. Okay, so here is example 2. A, and I'm going to factor this. Factor x squared minus 10x plus 25.
What does that say?
X squared
No,
minus.
the thing under the steps to factoring, the quote that you.
It's
Oh, what factors of constant? So what's the constant in that trinomial? 25. What factors of that constant add to the middle term's coefficient?
You know what? I just.
Are we supposed to be factoring that?
Yep.
Okay.
So this is not something that we've gone over this so far this year. This is just a review from Algebra 1. So if you can remember how to do this, try it, go for it. If not, we're going to go over it together. So,
I think I have the answer, but I don't want to say because I think I'm wrong.
oh, so you're afraid.
Yeah, basically.
Okay, well, how about we'll do it, and if you're right, you can tell it, and we'll just trust that you were right. And if you don't say
Oh, I
anything,
think I'm right. Never mind.
okay.
I really have no idea.
All right, so Drew's still working.
Yes. Got it. Okay, go ahead.
You good? All right. So,
I'm right.
what's the first thing you should start with, Tori?
Not to worry.
But
cheeks and tats.
Cheeks and tats. All right. So this is gonna end up being like this. I'm not gonna explain what cheeks and tats is to you if you haven't had me before. You might want to ask Tori. She
You're
would love
pretty
to
good
tell you.
visual right there.
Yeah.
Pretty self-explanatory.
I know it's kind of awkward to look at now. Ew. Okay, so this is the opposite, going backwards, of foiling something. This was the opposite of just distributing one thing to a parenthesis, right? But now this is the opposite of foiling. Remember we did foiling last week. Multiply the first times the first, and you get that, right? Multiply the outside and you get an x term. Multiply the inside, you get an x term, and those will combine to this middle term. Remember the FOIL process?
Yeah.
And then the last term, these two numbers will multiply to get that. Okay, so now to think backwards, all right, so these two numbers have to equal 25 when you multiply them together. But then when you combine these to this negative 10, it's this product plus this product, because those are like terms. Remember, the middle terms are always combined when you FOILed? Well, that's what's happening. When you combine something, you're just adding the coefficients. So the coefficients are formed when you multiply this times the x, you get like 5x or something, and 5x. So what first of all, these two numbers also have to multiply to get 25, but that's why they have to add to get this negative 10. Okay, so what two numbers multiply to get positive 25, but when you add them together, we'll get negative 10.
5 and negative 5.
Okay, is that what you got, Drew?
Yeah.
All right.
Yeah, maybe.
So now I'm gonna write it out, and then I'm gonna FOIL it. Because here's what your brain needs to do. To learn how to factor a trinomial, part of the learning process is checking your work. Because your brain has a hard time determining whether you're doing something forward or backwards. Okay? And if you're dyslexic, it has a really hard time doing that. Okay? And to your brain, sometimes forward and backwards is the same process. So let's multiply, let's do this forwards. So x times x, FOIL, x squared, outside, negative 5x, inside, negative 5x, last 25, combine the middle terms, x squared minus 10x plus 25, check. Okay? So this question here, what factors of the constant, there's only one constant, it's 25. If there's more than one constant, then you should combine like terms and simplify it before you factor it. Okay? What factors of the constant, 25, add to the middle term's coefficient? Well, there's only two factors of 25 that aren't 1 and 25. And 1 and 25 is still on the table, but we know those won't add to get negative 10. Well, 5 times 5 is 25, but 5 plus 5 is positive 10. But you know what else equals 25? Is negative 5 times negative 5, because a negative times a negative also equals a positive. So even though it looks like there's only a a couple numbers that work, 5 and 5, you also have to consider the possibility it could be -5 times -5, all right? Now, this is what's called a square trinomial. Square is something that's square rootable, right? Is there something times itself that equals this?
Yeah.
Yeah, x minus 5. Okay? So how do you tell if something's a square trinomial? Do you guys remember this? You can tell right away that this is a square trinomial. Does anyone remember that? Do you remember completing the square?
I remember, I just don't remember how to do
Yeah.
it.
So here's another square trinomial. Ready? X squared plus 6x plus 9. Here's another square trinomial. X
I have
squared
an idea.
plus 12x plus 36.
Okay, yeah, I think I know.
All right.
It's like if the exponent keeps going down, like it was 2, and then it's... No, that's not right. It's
That's just what
No.
makes it a trinomial.
X squared plus, let's see, 18x plus 81.
Well, I can see
And
the...
really, it could be.
They're all perfect squares.
Yeah, but how can you tell that it's a perfect square?
Because it's...
If you factor it, then it's a perfect square. But what are you doing to factor it? Well, do you remember this trick? You take the middle term coefficient, you divide it by 2, and you square it. 18 divided by 2 is 9, square it is 81. 12 divided by 2 is 6, square it is 36. 6 divided by 2 is 3.
I do not remember that.
So that's what we did when we did completing the square, and we'll revisit that. But for now, if you just factor it, then you can tell it's a perfect square. Because what two numbers multiply to get 81 but add to get -18? Well, -9. What two numbers multiply to get 36 but add to get 12? 6 and 6. So you don't have to remember the shortcut right now, but just know that this is called a square trinomial. All right? This is not a square trinomial because when you factor it, it's not the same thing times itself. That's what a square is. When you factor it, it's the same thing times itself. Okay, 25 is a square because when you factor it, it's just 5 times itself. All right. So this is basically when you if you can recognize that this is a square trinomial, all it is x, this operation symbol, and half of that. That's how you factor it. So how do you factor x squared plus 12x? Well, it's just x plus, because that's the same operation as that, half of 12, which is 6. So that's how you factor that.
Oh, that's
X plus
easy.
6, parentheses squared. So how do you factor this?
X minus 9.
X minus, same symbol as that, half of that is 9. That's the shortcut, okay? Do you have to remember the shortcut?
Yes.
No, you don't, but it's very
Makes it a
helpful.
lot easier.
Yeah. You can just factor this normally. What two numbers multiply to get 81, but add to get -18? Well, -9 and -9. Well, see how that's the same. I just wrote it with the exponent. It's the same thing as this. X minus 5, x minus 5, or x minus 5 squared.
So like on a test, will you accept either answer?
Yeah, I will.
Okay.
If it says write it with an x, I mean, it won't say that.
Like, is there like would one of them be more simplified than the other one? Like,
Technically, this is more simplified, right?
Okay,
Because
yeah.
what is the general rule of simplifying is to write it with as least amount of ink as possible.
right.
Okay, so that would technically be more simplified, but it means the same thing.
Okay.
Okay, so that's a square trinomial. And then the last one is the difference of two squares. So let's do one. Okay, well let's do this. Let's Okay, so it gets tricky. Let's do 2b here. Let's move on to example 3. Here's what example 3 says. I want to factor this. Factor x squared minus 49. Factor x squared minus 49. Anyone know it right away? If you don't know it in 3 seconds, then you don't know the shortcut, which is fine, but we're going to go over that. Not squared. So this isn't a square trinomial.
Wait, factor x minus.
X squared minus 49.
Do you do it butt cheeks and tats?
Yeah.
So it's plus 7 and then minus.
Yes. So it's x plus 7, x minus 7. So in order to get rid of, because really this, guys, is just x squared plus 0x minus 49, right?
Yeah.
So what two numbers multiply to get negative 49, but when you add them together, we'll get 0. Well, 7 times negative 7 is negative 49, but 7 plus negative 7 is 0. So you can still ask that same question, but the shortcut is just square root both of them and then add and subtract. So see how I square rooted both of them. And I'm going to add and subtract. Or subtract and add, doesn't matter. Okay, difference of two squares. Nice. I like it when I recognize the difference of two squares. Okay, so when you solve a polynomial equation or a quadratic equation or a trinomial equation, basically it looks like all this, except it says equals something, right? Or equals 0. So your goal to solve by factoring is first you need to factor it, and then you have to figure out what x's will make that equation true. The easiest way to do that is to put everything on one side with 0 on the other. Okay? So let me erase this and start a new page here. Okay, so this is example 4, and this is solving a quadratic equation. So I'm going to solve this guy, x squared plus 3x minus 10 equals 0. Okay, so now I'm going to write in this box steps to solve quadratic equation, quad EQs, by factoring. First step, get everything on one side and 0 on the other. Everything on one side with 0 on the other. Okay, so x squared plus blah, 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 all equals 0. Okay, first step is already done.
Okay.
Second step, guess what the second step is? Just guess, just guess.
What was the first one? Oh.
Get everything on one side with 0 on the other, which is already done there. Okay, so what's the second step?
So erase the 0.
Erase the 0.
I don't know.
Is it greatest?
Yeah, but what you're doing is factoring. So factor, and then you can refer to these steps. So is there anything in common on that left side? Anything they have, those three terms have in common? Nope. So second step, look for a difference of two squares. Is there a difference of two squares? Yes, Mo.
It says other side dot 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 x squared, correct? Plus dot 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 and then a square.
Yeah. So this is what it will look like. X squared plus something plus, I don't know. It's just an example. So everything's on one side with 0 on the
The
other.
key or plus sign?
That's a plus sign.
Okay, sorry, I can't see it.
Oh, and you are
Why would
looking
you
at it
put a
literally.
key in an
A T. She said T.
I can't read right now. My eyesight is just.
I know, zero.
Okay, so it's not a difference of two squares because it's three things, right? It's not two things. So now our only hope of factoring is it's a factorable trinomial. So what's the magic question you ask? Is there two numbers that multiply to get -10, but when you add them together will come down to a 3?
No, not really.
Oh, there is.
Right.
+5 and -2.
Okay.
Okay? 5 times -2 is -10, right? But 5 plus -2 comes down to 3. So when you FOIL this out, and if you're still not getting these are my favorite because it's just a puzzle. It's a riddle. What two numbers multiply to get this, but add to get this? But if you don't know it yet or don't enjoy it yet, then you don't fully understand it. Because if you fully understood this, then there would be an element of enjoyability. I think they call that joy, I guess. To enjoy something is to feel joy. But if you're not feeling some version of joy when you factor this, then you don't fully understand it. Because I promise, and maybe it's not Elitch's joy, like, yay, okay, but it is a sense of satisfaction, like, yes, nailed it, okay? When you solve a crime or when you solve a mystery, I figured it out, okay? There's joy to be found in these problems.
All the hundreds of crimes and mysteries I solved.
All right, so this still equals 0, okay? Well, this is just two things being multiplied to get 0, right?
Yeah.
So how do you get 0 as an answer to a multiplication problem?
Multiplied by 0.
Yeah, one of them has to be 0, okay? So either this has to be 0, x plus 5 has to equal 0, or x minus 2 equals 0, right? Because if, well, first of all, x here would have to be -5 for that to be 0, and x would have to be 2 for that to be 0. If x was 2, this would be a 7, but this would be a 0, and anything times 0 is 0. So see how you've got two answers. And we knew that going in, that we could have up to two answers because of that exponent. That degree tells you how many possible answers you might have, okay? You'll never have more than two, but sometimes you'll have one answer, sometimes you'll have none, okay? But if the highest exponent is 2, then you could have up to two answers. And here's proof. It could be -5, because -5 would make this 0 times -7, which is 0. And a +2 would make this 7 times 0, which is also 0. But that's it. Those are the only x's, those are the only numbers that will make this equation true.
So what's
So,
the answer?
The answer is x could either equal -5 or 2. That's it. That's how you write your answer.
Okay.
So there's two x's. Now you can leave them separate, x equals -5, x equals 2. Or you could just write it x equals -5, comma 2.
Okay.
Okay? So, and whenever you get to this point, you have to, it's almost like, wait a minute, I thought it was 5 and -2. And you said the answer is -5 and 2. Well, no. 5 and -2 is how you factor it. But then how you solve the equation, you have to flip it around. Okay, what's going to make that 0? Well, what makes things 0 is when you add the opposite. Okay? So to 0 that out, you need a -5 added to that +5 that you needed for factoring that. To 0 that out, you need a +2 combining with that -2 that you used to factor that. Okay, so it's always going to turn around again. There's going to be a little 180 happening when you're solving by factoring. You're going to have to oppositize something in your brain at some point. Okay, don't take my word for it. Plug it in, see if it works. Okay, So when you're doing this on your SAT, please do that, because the most common mistake is to stop right here. Oh, so x equals 5 and negative 2. No, solve the equation. All right, that's solving by factoring. We'll stop there. Let's do, I'm just going to do one more example. I know I don't have a lot of time, but. Okay, because 24 is, we've already been talking about 24, so lesson 23, I'm going to do one more example. Here's example 2b. I want to factor this. Four m squared plus 12 mn plus 9n squared. Okay.
And you want us to do that?
Yeah. Yeah. All right. So to factor this, you still start here. Okay. But the difference between this and what we've been doing before is that magic question doesn't work. Okay. So because to FOIL this out, how do you get that first term? It's the first times the first, right? What times what equals 4m squared?
2m.
2m, you could say 2m and 2m.
Okay.
All right? Now, let's just for the
But
fun
it
of
could also
it.
be 1m and
And
4m.
yes, it could be. But we're hoping this is going to be an easy, like, square trinomial, which it is. Okay? Now, what times what equals 9n squared?
A lot of 3n.
3n and 3n. Now, what happens when you FOIL it out? You get 4m squared plus 6mn
Look at that.
plus 6mn plus 9n squared. Combine them together and you get 12mn.
Oh.
Now, here's the deal. See how that magic question, what two numbers multiply to get 9 and add to get 12? 3 times 3 equals 9, but it doesn't add to get 12. Because when you FOIL it out, you're not just adding the 3 and 3, you're adding the 6, because that's what happens when you multiply. Up here, when you multiply, it's just 2 squished up against x, 5 squished up against x. So those numbers are added because they end up being the coefficients. Over here, 3n times 2n, 2m is 6mn, so that doesn't work. But for now, we're not going to get too crazy with this. If you see something like this, it's probably a square trinomial. So just square root the first and the last, and then hope and pray that everything will work out, and it will for now. We'll get more complicated later, but for now, it's probably a square trinomial. So square root both, and instead of adding and subtracting one, we're adding both or subtracting both, okay? All right, lesson 24. This is just